Hi everyone, today I would like to introduce the Krebs cycles under starvation, which is without food.
Now, let's revise back what is in Krebs cycles. First, glucose undergo glycolysis and become pyruvate, and the pyruvate forms acetyl-CoA by a link reaction, which is still not yet involved in Krebs cycles. The acetyl-CoA then enter the Krebs cycles by reacting with oxaloacetate and become citrate. During starvation, gluconeogenesis starts. PEP carboxyl kinase will convert oxaloacetate coupled by GTBA back into phosphoenolpyruvate, and phosphoenolpyruvate will convert back to glucose. It can also undergo gluconeogenesis and enter Krebs cycles. Triacylglycerol consists of glycerol and fatty acid chain. Glycolysis cleave triacylglycerol. Glycerol will become dihydroxyacetone phosphate, and fatty acid chains will undergo beta oxidation and become acetyl-CoA. The acetyl-CoA oxidizes from fatty acid chains that enter the TCA cycle. Fatty acid chains with odd number of carbon will undergo beta oxidation and form acetyl-CoA and propenyl-CoA. The propenyl-CoA produced by odd number carbon fatty acid chains convert to succinyl-CoA by respective intermediates and enter a Krebs cycle. Amino acids that involve in gluconeogenesis can also enter the TCA cycle. Arginine, glutamine, glutamate, histidine, and proline can convert to alpha-ketoglutarate and enter Krebs cycles. Isoleucine, methionine, threonine, and valine can convert to succinyl-CoA and enter Krebs cycles. Phenylalanine and tyrosine can convert to fumarate and enter Krebs cycles. Asparagine and aspartate can convert to oxaloacetate and enter Krebs cycles. Last, leucine, lysine, phenylalanine, tryptophan, and tyrosine can convert to acetyl-CoA and enter Krebs cycles. Now, we'll talk about the electron transport chain under starvation. Let's recall back the ETC. Electron transport from complex 1 to complex 4, and oxygen will be the final electron acceptor. A proton gradient is created and chemosmosis caused by proton motive force stimulate the production of ATP. How starvations affect ETC? As we know, gluconeogenesis and ketogenesis require ATP. Hence, ETC need to produce more ATP to undergo this reaction. Besides that, beta oxidation of acetyl-CoA will also increase the efficiency of Krebs cycles and ETC to produce more ATP. That oxidation will produce vast amount of ATP, and the ATP is very unstable. Hence, regulatory inhibitor is required. NADH will be a very good candidate. As Krebs cycles slow down, acetyl-CoA will accumulate.